This is example 2 from our class notes. Again, this is a single stage epicyclic gearbox, sun gear 45 teeth, planet gear with 18, annulus gear with 81. This time my sun is being driven. I'm also taking the link arm, in this case, which is mounted on bearings onto the shaft, and rotating that. So the sun gear is doing 63 RPM, my link arm is doing 9 RPM in the same direction, and I'm looking for what the annulus gear is going to do, which is connected to my output. So as before, construct a table. Sun gears, links and annuluses. Let's call this A, we'll call this one B, we'll call this one C. So this is A, this is B, this is C. First part is we now go all plus A, plus A, plus A. We now hold link, and we'll turn the sun gear, so we're going to go A plus B. So this one's going plus B, the link is being held. The annulus gear, again as before, this goes plus, this will go minus, this will also go minus because it's an internally cut gear. So this one will be minus B times the ratio between the two. I am turning the sun gear, I'm trying to find out where the annulus gear is going. Draw a line between the two and write the numbers in that order. Set of meshing teeth here, set of meshing teeth there. 45 over 18 times 18 over 81. So 45 over 18 times 18 over 81. Take those out. Next part is to add A plus B, A minus B times 45 over 81. Real speeds, sun gear is doing 63. My link arm in this case is doing 9. Both of them make them clockwise in the same direction. My annulus gear is the thing that I'm trying to find in this case. So obviously from here, A is equal to 9, A plus B equals 63, therefore B is equal to 54. My output speed will equal A minus B times 45 over 81, which is 9 minus 54, it's 45 over 81, which is equal to minus 21. Output equals minus 21 RPM, i.e. anti-clockwise. Output power I can't do as before, because now I've got power going in here, I've got power coming out here. In here I could have power going in or out, because this time it's moving, last time it was stationary in the first example. The only way to solve where I've got everything moving is to do a free body diagram for the planet gear and work out the forces acting on the surface of the teeth. So to do this, it's my sun gear, my planet gear, and my annulus. I know for the sun gear that I have 5 kilowatts at 63 RPM, so I can calculate the torque from here. So my input torque power is 2 pi nt, 5000 2 pi 63 over 60 t. T is going to be equal to 757.9 Newton meters. Now to work out gear force, we're going to assume that the number of teeth and the radius are the same. So let radius equal number of teeth. Now this assumption will cancel itself back out later. So in this case, torque is equal to force times radius. 757.9 is equal to the gear force times 45. My force is equal to 16.8. So on my little diagram, this thing here will have a force pushing on my gear of 16.8. Okay, this is my planet gear is pivoted on a pin. So this is a thing where it's able to rotate around that pin. So if I'm pushing here with 16.8, then I must push on the other side with 16.8 as well, in order that this thing will be balanced about that pin. So if that force is 16.8, then I must also have a force here of 16.8, and therefore on the pin there must be an opposite force equal to those two at 33.6. So this one here had a radius, we said, of 45. This one out here will have a radius of 81. So my output torque, remember my output was taken through my annulus gear. So my annulus gear had 81 teeth, so that's this one here. My output torque out will be equal to force times radius. My force, we said, was 16.8, and my radius was equal to the number of teeth, which is 81, which gives me an output torque of 1360.8. Output power, 2 pi nt, 2 pi 21 over 60 times 1360.8. Power out is equal to 3 kilowatts. So on my little free body diagram here, I'm going to have 5 kilowatts going in there, 3 kilowatts coming out here. Conservation of energy must apply. 5 in, 5 out. 5 in there, 3 out there. There must be 2 coming out here.